We have two given functions here, e to the power of negative x and e to the power of negative 2x. We are to determine the Wronskian of these two given functions. Now, identifying Wronskian is included in this playlist because there is an important process in solving non-homogeneous higher order equations where the previously discussed trial particular solution is no longer possible. Hence, there is a process involving Wronskian of functions, and that is why we have this here. Considering that we have these two functions, e to the power of negative x and e to the power of negative 2x, that is embedded in the problem, the Wronskian is actually identified as the determinant of a square matrix following the given functions. To do this, we should come up with a matrix placing both functions on our first column. And since we are determining a determinant, that would mean it should be a square matrix. In short, we only need to include here the items for our second row. This is also supported by the idea of this formula, which tells us that per column, from the original function, the next entry of that column would be its derivative, and then so on and so forth, and we stop at the point of n minus 1. We have two functions here. This would mean we stop at 1. In short, we only stop at the first order derivative, and hence, it will complete the second row. Okay, the derivative of e to the power of negative x is itself, but we also need to multiply it with the derivative of the exponent. So you have negative times negative 1. For our second column, let me move this here. Okay, it should also follow the same. The derivative of that is itself times the derivative of its exponent, negative 2. Okay, so with all this, we have now established a 2 by 2 matrix, and hence we can now solve for its determinant, or again, in short, the Wronskian of two functions. But of course, this is simplified to be e to the power of negative x, e to the power of negative 2x, and your second row would be negative of e to the power of negative x and negative 2 of e to the power of negative 2x. The Wronskian or determinant will follow, of course, the process of multiplying the entries per diagonal. The red one will be positive, and then we're going to subtract the result of the blue one. So doing this, the Wronskian of e to the power of negative x and e to the power of negative 2x is equal to the red one, e to the power of negative x times negative 2 e to the power of negative 2x, and then minus negative e to the power of negative x and e to the power of negative 2x. Simply multiply and simplify them, remembering the processes involved in laws of exponents. So you have here negative 2, then you have e to the power, you add the exponents because we have the same base, negative 3x. Then you have here negative times negative plus e to the power of, you will have here negative 3x. Since we have this as our factors, so we can just simply combine the numerical coefficient negative 2 plus 1 here. That would mean the Wronskian of the two functions is just equal to negative of e to the power of negative 3x. This will be further used if we have a situation involving these two functions on the process in solving non-homogeneous higher order equations. Thank you very much for watching.